How do you
how you clean that like straw?
the straw? Well, they actually sell like a really really long bottle cleaner thing. So you can actually try to squeeze that thing in. Yeah, it to me it just doesn't make a whole lot of sense. It just doesn't make sense. This is so much easier. Even if I do have to wash it, it opens up. So it's easy to wash.
Yeah.
Yep.
I would use those metal ones.
Yeah. With the metal ones, you can stick it inside a pressure cooker. Then you can really clean it.
Yeah, it said has everything.
Yep. It's called a autoclave. Yep. That's how they clean up like test tubes and whatnot in the lab. Yep. All right. So let's go ahead and get started. There were a few people, not just one, but there were a few people asking for some additional programming examples. So that's why I got 4B and 4C. So those are two additional questions that you guys can use for practice purposes. You have a new homework assignment, which is sort 4 variables. Okay, so instead of finding the maximum of 4, you now need to sort 4 variables, W, X, Y, and Z. So W has to be the lowest one, and the Z ends up to be the maximum, the largest of the 4. Okay, so that's your new homework assignments. I'm just going to show you what it is. It's not much different from the other one. So once again, you start with a zip file that I provide for you. I will download it and show you the content. It's about the same as the previous one. This time I will have when you unzip the file, it will create a folder called sort4 instead of control, and it will also have a source code file called main.cpp. But in this particular case, once again, you will have comments, and you can only insert your code between the 2 lines of comments. The objective of your code is to I forgot to update it. Your objective is to sort the variables W, X, Y, and Z. So W ends up to be the smallest of the 4 numbers, and Z ends up to be the largest. So you want W to be less than or equal to X, W, and X is less than or equal to Y, which is also less than or equal to Z. So you want to do the sorting instead of finding the maximum. Yep.
Can we use the previous code?
Can we use what?
Can we use the previous code plus some more stuff?
If you think the previous code is going to be helpful, yeah, by all means, you can recycle code from your previous program. This program has the logic to interpret the command line arguments, just like with control or find maximum. To run the program, simply use the executable name followed by 4 integers on the same line. So in this case, main 12, 34, 56, 78. And in Linux, you have to use / to in front of the name of the executable. My code will print the values of variables W, X, Y, and Z in that particular order, so you don't have to worry about printing anything out. It is already going to be printed. Yep.
So it doesn't matter what the values are?
Sorry?
It doesn't matter what the values are of the W, X, Y, or Z?
Which part does not matter?
Like, does it matter, like, is W always be 0?
No, W is... Okay, so the command line will specify 4 numbers.
Yeah.
And so your job is to sort those 4 numbers and store the smallest one of the 4 numbers in W and the largest of the 4 numbers in Z.
So we don't change the value?
You cannot change the value, right? Because otherwise it would be pretty easy, right? Just print 4 numbers that are already sorted. 1, 2, 3, 4. It's already sorted. I'm done. Yep. Yeah, I forgot to update the notes here. So my program will print out all 4 numbers, so you don't have to worry about it. But it's not going to print the maximum. So it's not about finding the maximum. It's about sorting. So just remember that part. All right. So let me go ahead and just kind of show you what the code looks like. Sort 4, and once we know that part, the rest should be pretty easy. So unzip sort 4, and it creates a folder called sort4, and in it we have main.cpp. So this is main.cpp the way it comes with a zip file. The first part is identical to the program that you just turned in. Okay, I use exactly the same code to interpret 4 numbers from the command line. So that part is no change, exactly the same. we have the two lines here. Insert your code below this line and insert your code above this line, same as your current homework assignment. So your code can only go in here. Okay, it's not just one line. If you want to use 200 lines, that's fine with me. Okay, I'm not saying that you have to use only one single line to accomplish sorting for variables. So you probably will end up with a longer program this time compared to last time, but hopefully it's not going to be really a whole lot longer. Okay, it's just going to be a little bit longer. And then instead of printing max after your code, I have a loop here to print all the variables w, x, and y out. Well, I'm using a loop to do it, because I have an array of pointers to point to each one of those variables, and that's why I can do this. But in your code, you are not going to use a loop. Okay, if you look up on Wikipedia how to do sorting, most of those algorithms will not be directly applicable, because most sorting algorithms require the concept of arrays, and we have not talked about arrays yet. W, X, Y, and Z are not an array, so the array approach is not going to work. Okay, so you will have to find out how to do it. Since you already know how to find the maximum of 4 variables, that is going to be helpful. Okay, so what you need to do is to kind of borrow some of the code from the current homework assignment, or the one that was due like an hour and a half ago, and then use that as the basis of this particular one. Yep.
So when you enter the pointers to the command prompt, are they already assigned to a variable?
Yes. When you enter those 4 numbers, the first one goes into W, the second one goes to X, just like with your current but just like with the one that is due today. Okay. All right, so what I'll do next is to give you the solution of the homework assignment that was due today. Okay, because that's something that I always do. If I forget to do it, if it's a due date of a particular homework assignment and I forget to mention the solution to the homework assignment, you can remind me and say, oh, there's a homework assignment due today. We want to know the solution or how you would solve the problem. So I will talk about it today. All right, so let's go to control, and I think it might be here already. Yep, so control is here already. So we'll look at the code, the source code of control or main.cpp of the previous, or the homework assignment that was just due, and we'll go ahead and specify the code here. Now, what I want to specify here will be the code to find the maximum of 4 variables, and there are many ways to do it. Okay, there's one way to use a structured conditional statement. So every single time you compare, you only have to compare and know how one variable relates to another variable. That's one way to do it. You can use conjunction and basically say, if W is greater than or equal to X, and W is greater than or equal to Y, and W is greater than or equal to Z, then W has to be the maximum. Else if something else, and so on. Okay, that's the other approach. You can also do it, sequentially. In other words, you just say, let's maximum be W, and then use a conditional statement and say, is Y greater than or equal to maximum? If so, Y becomes the new maximum. And then you choose, well, W, X, and then Y, and then Z. Okay, so that's the kind of more sequential way of finding the maximum. So there are many ways to arrange the logic and get the same thing done. So they are all correct. There's no one particular, way that is actually better than the other ways. So I'll show you the first way first. Okay, the first method. The first method is basically just to say, okay, let's before I can see the other variables, if the only one that is presented to me is W, W has got to be the maximum, of the 4 of the 1. Okay, because we are only looking at one single variable at this point. Now we introduce X. So we say, if X is greater than the current known maximum, which just turns out to be W at this point, we'll go ahead and update it. So in this case, we'll update it and say, since X is larger than what we currently know as the maximum, then the current maximum should be X instead. The else has nothing to say. I mean, we got nothing else to do here. and then you say, oh wait, there's another variable called y. Maybe y is larger than the maximum known up to this point. So you basically just have to keep doing this until you're done with all the variables. So if y is larger than the maximum, then obviously the maximum should be y and not x anymore. And the last one is to say if z is greater than maximum, then z is the maximum. So the maximum should be the same as z and not the previous one. So this is one way to do it. It works. Okay. The logic is fairly simple, and you just have one single comparison each time, and a conditional statement and an assignment statement to say, oh, okay, what we knew or what we thought was the maximum, it's not the maximum. This is actually larger. You keep doing this 3 times, and then you're done. Any questions about this approach? Well, I'm not 100% sure this is actually going to work, right? So let's go ahead and test it. Do you guys want me to save it and upload all of these files? Okay. In that case, I will have to kind of rename these things here. So I will have to copy this one to main1.cpp, and we'll go ahead and test it. G++-1 all dash then tick dash G main1.cpp. Go. So, well, you have to give it 4 numbers on the command line. So we'll give it 1, 2, 3, 4. Okay, it prints 4 is the maximum. I can give it 4, 4, 3, 3. It prints 4. You can give it 3, 4, 2, 1. It prints 4. So I'm going to give it a lot of test cases, to grade this one. But basically, I'm fairly sure it is working now. Are we doing okay so far with this approach? How many people did something kind of like this? Okay, very good. All right. So now that we have main 1 that is working, let's go ahead and take a look at main 2. So I'm going to cp main1.cpp to main2.cpp. And main 2 is going to be based on the same logic as main 1, except I'm going to use a ternary operator instead of a conditional statement, because it just makes it look nicer. That's one way to describe it. So I would just say, max, depending on whether x is greater than max or not. If so, x is the maximum, use it to update max. Otherwise, max can keep its own old value. So this is a more concise way to represent the same stuff that we have talked about earlier. And because I still want to do it sequentially, so that means I just have to replicate it a few times, change the variables in each one, and it should do the same thing.
How did you replicate that?
Huh? YY to yank a line, lowercase y, because it's case sensitive, to yank a line, and then PPP, lowercase p, to paste. Yeah, VI is not easy to learn, but once you learn it, you don't have to move your hand to the mouse ever again, which is kind of cool. All right, so let's check out whether this works or not. Okay, this is main2.cpp. So we'll go ahead and G++. Okay, I'm just going to be lazy. Repeat the command here. So we're dealing with main2 here. And we say main2 test 5, 3, 2, 1, prints 5, 5, 5, 3, 3, prints 5, 5, 3, 5, 3, prints 5, and so on. It seems like it's working. All right. Let's go for some other approaches. So let's go ahead and copy main.cpp to main3.cpp. This is the third way to do it. I'll probably end at about the 5th alternative or so, because otherwise we can keep doing this for a long time. Okay, this is line 44. I want to remove all the code in this case. So 44 to the current line, delete. So now I can start all over again. Okay. So with this approach, I only use one single comparison each time, and I'm using a nested conditional statement structure to get this done. So in this case, I would first compare. You can pick any 2 variables to compare. I'm just going to pick W and X first. Okay. Okay. So right here, I'm saying W is greater than X already. So that rules X out as the maximum. Okay. So I can comment and say X cannot be the maximum. The other three can still be. Over here, I'm using it's corresponding to W is less than or equal to X. So I can kind of rule out W, okay, because even the W can still be the maximum, it can be the same as X also. So I can say W cannot be the maximum or will not be considered as a part of the maximum. Okay, I should make it more clear. Is not considered a maximum because it covers the case of W and X being the same, but I can still pick X and get the same value. Alright, so in this case, since W is greater than X and so X cannot be the maximum, I still have to check with the other variables and see which one is larger. So now I can compare W with Y. Okay. If W is greater than X and W is greater than Y, I still have one more to check. So in this case, X and Y cannot be my maximum. So I have to check the other one, which is Z. If W is also greater than Z, that means X, Y, and Z cannot be my maximum. So my maximum has got to be W itself. So max equals to W. What about this one here? What should I conclude here? Z is the maximum. Okay, max equal to Z. Right. So this else here is corresponding to W is not greater than Y. So in here I can say Y can be the maximum. So Y or Z can be the maximum. So we have to compare those two. So we now compare Y to Z. If Y is greater than Z, then Y is the maximum because now I know how the four variables relate. So we have max equals to Y in this case. Otherwise, Z is the maximum. Alright, so we can do about the same thing over here, except in this case, I'm ruling out W as the maximum. So now we have X, Y, and Z as the potential maximum. So now we compare X to Y. I mean, you can see the general pattern here, right? So if X is greater than Y, then X or Z can be our maximum. Then we check whether X is greater than Z or not. But since I'm down to two potential maximum at this point, if X is greater than Z, then the maximum has got to be X. Otherwise, the maximum is Z. In this case, X is less than or equal to Z, so that means, oh wait, hold on a second. This one is corresponding to X is less than or equal to Y, so we have to look at Y and Z as the potential maximum. So we're comparing X, Y, and Z. If Y is greater than Z, then Y is the maximum. Otherwise, Z is the maximum. So this one is a little bit lengthier. You can definitely tell. Yep, go ahead.
So, just curious, if you put the double equal sign, the max equals Z or Y or...
Double equal here.
Yeah, double equal, it doesn't say anything, right?
It doesn't do a thing. Well, it will do the comparison, but nobody cares about the answer to that question. So in the end, nothing really gets done.
Okay.
Because it's really just comparing and not changing the left-hand side to the right-hand side. Yep. All right. So let's go ahead and test this one. And this is main 3. So we'll go to the command line to compile everything. And we'll say main 3, 1, 2, 3, 4, prints 4, 4, 3, 2, 1, prints 4, 3, 4, 2, 1, prints 4. So, I have some confidence this is working correctly, okay? But I cannot prove that this is working correctly the whole time, for all cases. Are there any questions about main3.cpp, the one that has the structure code? Yep.
So, can we go back to the source code?
Absolutely.
So, the parts where it says like x and y cannot be max, and then if w is greater than z, do we have to state like x and y cannot be max?
No comments is really just for your own benefit.
Okay.
So I cannot keep track of a program like this without the comments. That's why I wrote the comments.
Okay.
Yep.
So it doesn't affect code.
It is not required.
Okay.
Yep. But in general, if it only takes like a few seconds to type it, but it can potentially save you minutes of looking at the code and go like, okay, where am I here? What am I doing here? Then it's worth those few seconds to type it.
Okay.
Yep.
Can you do the test on this code?
Say again?
Can you do the test 3342?
Can I?
3342 for this one.
3342.
Yeah.
Okay, sure. 3342.
So
Okay.
you can specifically tell the W to compare to X if it's equal, so how come it's still going to the if statement if it doesn't compare? You didn't compare if X and W equal together. You did compare
The else takes care of when they are equal. Now, when X and W are exactly the same, then I can say, okay, let's not consider W. Let's just consider X because they have the same value. Because okay, let me go back to the source code so it's easier to refer to it. Okay, so in the first conditional statement, it says, if W is greater than X, right? So that one is pretty clear cut. X cannot be the maximum. Okay, so if we go to the else of this one, oops. If you go to the else of that particular condition, then I'm just gonna say, because W is less than or equal to X, let's not consider W to be the maximum. Let's just take X to be a candidate of a maximum. Because in the case that W and X are exactly the same, I can still use X as a candidate instead of W as a candidate. But in the case that X is actually greater than W, then I should always use X as the candidate. So I might as well just say X is the candidate and let's forget about W, because W can only be as large as X is. Okay, so let's look at yet another approach to do this. Okay, so we'll cp main.cpp to main4.cpp. Okay, so with this one, it is a little bit more structured, more kind of, you can replicate the code a little bit easier. So let's go to this line here and delete all those lines so we can start from scratch. So with this one, this is a tricky one, because with this one, you can also make mistakes and it won't show up easily. The mistake, will not show up easily. So I'm gonna show you. Some people know this one already, because if you took cisp360 from me, I intentionally make this mistake, when I talk about this algorithm. So I will say if W is greater than X, and W is greater than Y, and W is greater than Z, and quite obviously, W is the maximum, right? Mm-hmm. So we say, max is W. Otherwise, now you can use a construct like this, but it's not really a multi-branch conditional statement. It is actually a nested conditional statement in this case. But you can still write it this way, kind of see it as a multi-branch conditional statement, but in truth, it is not a multi-branch conditional statement. But I'm gonna use this format here and say, okay, I know W is not the maximum, so let's consider the other three. Okay, so we can say, let's look at X here. So if X is greater than, now this is where the problem is. Okay, so we can say if X is greater than W, and X is greater than Y, and X is greater than Z, and obviously the maximum is X. and then we can repeat this approach, like say y, compare y to all of the other variables. If y is greater than w, and y is greater than x, and y is greater than z, then the maximum is going to be y. And the last one, I don't need to do any comparison, because if w, x, and y are not the maximum, then the maximum has got to be z. Is that okay so far? Okay, the logic seems okay, but it is actually incorrect. Okay, so let's go ahead and see what happens when I run this program. This is this is main 4. So we have, let's go ahead and compile the program first. Main 4, and we'll give it the usual 1, 2, 3, 4. Okay, seems to work just fine. 4, 3, 2, 1 works just fine. 3, 4, 2, 1 works just fine. And the last one is 3, 2, 4, 1 works just fine. So why is it not working? Well, let's see. Let's try 4, 4, 2, 1. It's not working. Okay. So why is it not working when we have duplicates? Yep.
Because you're using just greater than instead of greater than equal to.
Yep.
If you have 2 of them that are maximum, and you're saying it's only going to equal that variable if it's greater than all the rest of them.
Yep. Yep, exactly. When you have duplicate maximum, in this case, because I'm using straight greater than for all of the conditions, it's going to fail all of the conditions, right? Because 4 is greater than 4 is false. And every single condition is a conjunction involving the comparing of the 4 versus the 4. So we will fall all the way down to the else case and say, oh, z has to be the maximum. But z is not the maximum in this case. Yep.
If the code that was terminated 2 hours ago has a comparison, w less than or equal to x, then this test will pass, correct?
If w is greater than or equal to, if you change it all to greater than or equal to, then it will work. There are several ways to fix this program. Okay. Yep. Go ahead.
What happens if you put all 4s?
If you have all 4s, then it will still work, because you can pick any one of the 4 variables and it will still be the maximum. But 4, 4, 4, 1 is not going to work. It will still pick 1 as the maximum. So basically, anytime you have 2 variables of the same value and they're both the maximum and they're not the last one, it's going to break this particular algorithm. There was a, and yep, go ahead.
Could you just put, instead of max equals z, instead of else, could you just put if
Okay. Okay, so I'm going to go ahead and fix this program. So main4.cpp can be fixed, and there are several ways to fix it. One way to fix it is to change all the greater than to greater than or equal to. Because if you change it to greater than or equal to, it means, okay, it's okay for this variable to tie with another variable. As long as both of these are still greater than or equal to everybody else, we're still good, okay? So that's one way to fix it. And I will fix it, and just to show you that this approach is going to work. So this is line 44. Okay, so 44 to this current line, change all the greater than to greater than or equal to. That's why I like VI. This is not even regular expression yet, okay? And it's already doing something that I like to do. Okay.
Should write a book on how to use Linux and VI.
Oh, I probably use about 5% of all the features in VI.
No, I'm saying you should write a book about it. How to use it.
Yeah, 5% is already good enough for me. So we'll recompile the program and run it again. Oh, and give it 4, 4, 3, 1, and this time it works. Okay, just by changing the greater than to greater than or equal to fixes the problem. Okay. But this is tricky because this means you need to find the right test cases to make sure that your program works, right? Because without duplicates, okay, it works just fine. Even with duplicates, if the last one turns out to be a 4, in other words, before I fix the program, if the input was 4, 1, 1, 4, it would still work because Z is basically 4. So it works just fine, okay? So that means when you write an algorithm, when you write a program, you have to think about how am I going to test the program to make sure the program is going to work correctly for all possible cases. And that is a science all by itself. Okay, program verification is a science all by itself. How do we come up with all the test cases? In the ideal world, we don't want to use test cases to validate a program. We want to use mathematics to prove a program is correct. And some of you are starting to frown because you know that I'm going to say pre and post conditions. Derive the post condition of an entire program, and if it matches what you expect the program to do, then you don't need a single test case to test the program because it is proven mathematically that the program has to work for all possible cases. Now that is difficult because it takes a lot of time to go from the precondition to the post-condition of each statement, and to bring it all the way to the end of a several thousand line program is going to take a long time. It's not practical. There are people who try to automate this process, and that's the entire reason why Prolog as a programming language exists. It exists as a programming language because people want to use the computer to prove programs are correct. Basically it's called validation or verification. So it's tricky, okay? Coming up with the test cases is a little bit tricky to test your program to make sure it works in all cases. All right, so I'll give you one more because I said I will give you 5 different methods to do it, right? So this is the 5th one. So main.cpp to main5.cpp. And let me take out for line 44 to here. So this one is going to use the ternary operator, but it's going to use like a nested ternary operator thing to get this to work. So I'm going to say max is, okay, give it a condition. So the first condition is W is greater than or equal to X, and W is greater than or equal to Y. Yeah, you have seen this before. Okay, that's the condition. If that is true, then W is the maximum. Oops, question mark. W is the maximum. If not, I have another condition. I have another expression. But if you see me using one line for the open parenthesis and another line for the closed parenthesis, that means there's a lot of stuff to go in between. Yep. Oh, right. Colon. This one here. So what I need to put here is to say, okay, what if W is not the maximum? Well, then we have to decide whether it is X, Y, or Z. Which one is the maximum? Now, if I know that W is not the maximum, this time I got smarter. Okay, I'm gonna not even consider W in all the future comparison because I already know it is not a candidate. So now I can say, the condition. If so, this time X is the maximum. If not, let's go for another nested thing to see if Y or Z is the maximum. So in here, I just have to say, is X the maximum? Well, let's see. If X is greater than or equal to Y, and X is greater than or equal to Z, then X is the maximum. Makes sense because W is out of consideration already. I only got 2 more things to compare to X. So in here, I'm going to do about the same thing. I give it a condition. If the condition is true, Y is the maximum. Otherwise, I only got one left. It has got to be Z. So with this one, it's just between Y and Z. So I can just say if Y is greater than or equal to Z, then Y is the maximum. Otherwise, Z is the maximum. So this is the other way to do it, is to use one huge, big, long expression to do it. but you guys have doubts about this. It's like I look at this and go like, I'm not sure this is gonna work. Let's test it. I'm not even sure it will compile. In fact, I know it won't compile because I missed one semicolon at the end. Here. And the parentheses are not matched correctly either. This is the other nice thing about VI. If you put your cursor on the open parenthesis, it will highlight the closed parenthesis, and you can see there's nothing matching this one. So that means it's not, because I'm missing a closed parenthesis here. Oops. Now everything is matching up. Yep. So that's all good.
Are curly braces and parentheses interchangeable?
They are not interchangeable, but VI will match both.
Okay, so what's the difference?
What's the difference?
Like when using them?
A curly brace is the indication of the beginning and the end of a block statement, and parentheses is really just what you normally use parentheses for in an expression. Right, so let's go ahead and do this one. This is main 5. Oops, I still missed something. Okay, let's see. It's complaining about here expecting close parentheses before semicolon. Oh, okay, I know why. I have the semicolon. The semicolon should not be here, but I put it there. There we go. Because I have a closed parenthesis here, I cannot turn it into a statement just yet. So that's why. It's all good now. Let's test it with 5, 4, 3, 2. 5, 5, 3, 2, which used to fail. Okay, it's still okay. 1, 2, 3, 4. And I can give it all the possible test cases. I'm fairly sure this one works just fine. So are there any questions about the 5 different ways of getting the same thing done? No? Okay. Did anyone try to use a loop to do this? You can if you use my pint array, but since we have not really talked about arrays yet, so that approach won't work. Okay, unless you understand pointers and arrays, okay, and how to use a pointer to a pointer in this case. But if you understood all those concepts, you don't need to be here. I mean, frankly, you do not need to be here if you already understand all of those concepts. So by the time we get to arrays and pointers, we're going to come back to this particular program and kind of re-explain what the initial code is doing, what my code is doing. How did it get all the numbers into W, X, Y, and Z using only an array to do it? Okay, so I'll go back to this point and re-explain all that stuff. Okay, any other questions about control or finding the maximum of 4 variables? How would you guys like to have another homework assignment where you find the maximum of 40 variables? X01, X02, X03, all the way up to X40. Yep.
Well, if you teach us about the arrays,
Exactly. That is why we have arrays. Okay? Okay, very good. I'm glad that you still remember why we have arrays. Good. Okay, so with this out of the way, we're going to move on to the next, the current homework assignment, which is sorting. Okay, so how do you sort 4 variables? Now remember, this is not an array. I'm just giving you 4 numbers, and you have to figure out how to do something about the 4 variables so that they become sorted. So I'm going to give you a case where they're not sorted to begin with, 3, 4, 1, 2, and I want to sort this to 1, 2, 3, 4. How do you go about doing this? Yep.
well, I think you can do the same thing that we just did, find the maximum, minimum, and then store those in W and Z, but I don't really know what to do with the middle stuff.
What if I tell you you cannot have extra variables?
Well, you can use max after that extra variable and keep on changing it.
Max is no longer in this one. I took that variable out.
that just ruined everything.
Well, not necessarily. Not necessarily. Okay. So what you do? Okay, this is important. Yep. Go ahead.
I was thinking about it. Once you put in the numbers, say it's W, X, Y, and Z. So placing an if condition, yeah. You know, if Z is the smallest, then it gets the value of W, or vice versa. So the smallest gets the biggest value, and the biggest gets the smallest, and so they interchange.
Yep. You're right. You're on to the core concept of one sorting method. Okay, it's not the most efficient way to sort something, but it does work. Okay, so what you want to do is to focus on W first, and then the question is, who is supposed to be here? Okay, you have a value here already, but is that the value that is supposed to be here? I don't know yet. Okay, so what you do is you use something similar to what we have talked about today to determine who is supposed to be here. So in this case, through the code that we have just talked about today, you find out that, oh, y is the minimum of the 4, and so the value of y is supposed to be the value of w. Okay, so yeah, go ahead.
But how do you find that out without max?
You don't need max. I mean, you just need to compare. Max is there to keep track of the value of the maximum in your previous homework assignment. In this homework assignment, I don't need to keep track of the value of the smallest one. I need to know who has the smallest value at this time.
So we're going to use the double equal sign.
You'll be using the double equal? No, but you will still be trying to, in this case, you're finding the minimum. Unless you want to focus on Z, then you can still find the maximum. Okay, so the other way, all right. So let's say you want to keep as much code as possible with your current homework assignment, which is finding the maximum, right? So we'll be instead of focusing on W to begin with, now we focus on Z because Z needs to be the maximum, right? So you use exactly the same logic that we talked about today, except for a few approaches where max is changed all the time. But if you use the other method where we actually find out who has the maximum and then change max to that variable, that will still work. So through that logic, you find out that, hey, x has the maximum value of the 4, so that needs to go here, okay? But since you are not allowed to create new variables and have to use all the existing variables, you have to swap or exchange the values of two variables without introducing a new variable. Have we talked about something like that?
Yes.
Do you guys still remember the remember that code? Yep. So that's what you need. Okay. That's one of the questions in the mock exam. So you use that approach and say, oh, okay, we can just go ahead and exchange these two guys. So now it becomes 3, 2, 1, 4. Now once Z is determined, then you can say, okay, I'm done with Z. Let's focus on Y now. So with Y, it is supposed to be the maximum of these 3. If you know how to find the maximum of 4, finding the maximum of 3 is like easy, right? So you find out that, oh, W turns out to have the value that needs to go into the variable Y, so you exchange these two next. So now you have 1, 2, 3, 4, which is already sorted, but you don't know yet, okay? Because at this point, you have only confirmed that Z has what it needs to go here, Y has what needs to go here, but as far as X and W is concerned, you really don't know whether they are in the right order or not. So now you focus on X and say, okay, is X the maximum of these two variables? So you do that, and then you say, what is the maximum of these two? Okay, the maximum of these two turns out to be X already, so now there's nothing else to do. Because if you know that 3 out of 4 positions is correct, then the last one has to be correct as well. It's called the pigeonhole principle. Are there any questions about the approach or one of the many approaches to get this homework assignment done? It's not the only one, it's just one of the many methods. But I think this is the one that most people would pick because it just kind of makes sense. Yep.
So are you assigning the value of z to x and x to z?
You have to use what we talked about last time, one of the mock questions that we talked about.
XOR operator or
The exclusive or.
yeah.
Yeah, I cannot remember the question. Is it number 3? No, number 2.
Number 2.
Yep. So you can use something like this to exchange the values of two variables. Okay. Any other questions? No other questions? Yep, go ahead.
Are you still giving values between 1 and 10 or number of...
Out of range?
Yeah.
No, they won't be out of range. Exclusive OR will never get a number out of range because it's a bitwise operation. So there's no way it can result in a number that requires more bits to represent. Addition, on the other hand, can bump you over by 1 bit. Multiplication can bump you over by twice the number of bits. Right. All right. So does everybody have a kind of good sense of how to get started with this homework assignment? It will be a little bit longer, so give it more time on this particular homework assignment. But on the other hand, because you have done the other homework assignment already, so hopefully you know the commands and how to get into the editor, get into the compiler, and run the program. So that part will take you less time with this homework assignment, but the logic is going to take you a little bit more time. Right, so with that out of the way, we have time now to talk about the other 2 mock questions. The first one is here. Okay, this one is something that some people would know almost like right away. It's like, oh, this is not fair. I don't really get to exercise my mind and figure out how to solve this problem because I already know the answer to this question. So this one is, I give you an integer n. It is at least 2, guaranteed. And you have to find me the smallest factor of n and store that in variable f. Some people know this answer already. I'm hoping people who took cisp360 from me can instantly recall the solution to this one and go like, oh, I know it's exactly this. But let's pretend that we don't know, the algorithm already at this point. And the question is, how do I write the logic, okay, in C code to solve this problem? Okay, I give you an initialized variable n. Okay, it has a number that is at least 2, guaranteed. How do I find the smallest factor of that particular number? Now, you have to think about prime numbers too, because with a prime number, it is its own factor. So if I give you 3, then f has to be 3 because 3 is its own factor. So what do you think? How would you do this by hand? In other words, now if you do something by hand, you have to be careful and not to pick something that is entirely trivial. Like 2 would be entirely trivial because when you say, oh, what is a factor of 2? And in your mind, it pops up right away. It's like 2. You don't have to go through any systematic way to find out what is a factor of 2. Same thing goes for 44,000. Okay, with 44,000, instantly you say, oh, 2 is the smallest factor because you already know it. So what you want to do is to pick something that is bigger. Okay, something that's more complex that you cannot just instinctively and use little tricks, rules of thumb, heuristics, and say, oh, I know this has to be a factor of this number. So to show you an example of what I meant by that, I am going to give myself an example, and I'll pick something that is big, but not particularly big. And with this number, it does not fit any of the rules that we already know, right? The least significant, oh, you cannot see the most significant part. There we go. So with this number, I can't really know, I don't know right away whether it is divisible by 2. Well, I know for sure it's not divisible by 2 because it doesn't end with a multiple of 2. We don't know whether it's divisible by 3, or we know it's not divisible by 3 because if you add up all the digits, that number itself is not divisible by 3. It's not divisible by 5. So all the really basic stuff is not working, okay? So now you have to go through a much more systematic way to go through this and go like, okay, let's try this, let's try this, let's try this. So let's go ahead and give it a try. And I'm going to give myself a basic calculator. I'm not even going to give myself a fancy calculator. Really basic one, or a fancy calculator in basic mode, to be more exact. All right, so we'll go ahead and give it a try. So we'll do something that is apparently not so smart, because I'm going to start with 2. It ends with a 0.5, so we know there's a remainder to the division, so 2 cannot be a factor. Next up is 3. Now, is it wrong for me to do something like this? Can I potentially mistake that a number is divisible by a factor when it's not a factor? It's not possible, right? Okay, it has a whole number. It's not a whole number. I know it's not divisible by 3. And here comes something that's even dumber. Talk about dumb and dumber. This is dumber. What I did earlier was dumb. This is dumber. Because if it's not divisible by 2, why do I even bother by 4? But the question once again is, can I do this and mistakenly say, oh, it is divisible by 4? Can I make that mistake? No, I'm just doing something that is wasting time. But I cannot mistakenly get the wrong answer. Okay? And then the next one is dumb again. Okay? There's a fraction to it. Cannot be 5. And then we have dumber again. Because we tried 2 already, right? We tried 3 already. 6 cannot possibly be a factor. But what this is allowing me to do is to make it very simple. Okay? I start with 2, and then I try 3, and I try 4, 5, 6, 7, 8, 9. I don't have to pick just prime numbers to try. Okay? I can just try the next number up. Okay? That really helps to simplify the algorithm compared to, oh, let's only try prime numbers. Well, what are the prime numbers? Well, we will have another algorithm to come up with the prime numbers. Okay, so this was what? 6. So we'll try 7, 5, 8, 2, 1, divisible by divided by 7 is it's not a whole number. And at this point I'm getting lazy. So I will switch to a spreadsheet. Some of you have seen this already. Okay, so the number in question is 5921. So we'll say, we'll start with a factor of 2, and we'll look at the division. And with the spreadsheet, you can do a mod, so you can specify, this number divided by this number here, and we look at the remainder. And in this case, I'm going to change the equation a little bit, so it refers to this as $1, so it doesn't get changed. The next one is going to be this number plus 1. And now I can just copy the cell because it will automatically refer to this one. So I can just do this and figure out when we get to 0, right? Okay, I think I can stop now. What? Really?
We gotta go.
Let's see, 50, 50, 2500. I think we have to go a little bit further, right? 50, 50 is 2500. What is the square root, or approximately the square root of this number? 70 times 70. So I would say by the time we get to 80 times 80, we can stop. Or when we see a 0. Okay, I know for sure that we can stop now. Okay, I know for sure we can stop now. Okay, some of you still remember why we can stop this early. Some of you may not know or remember why we can stop now. So I'm going to explain what I'm doing here. Okay, now this approach is fairly simple, right? For the most part, I'm just saying, okay, bump up to the next number, look at the remainder of the division, bump it up again, look at the remainder again, bump it up again, look at the remainder again. So if I really don't stop here, this early, I can kind of confirm this and stop at the right point. I'm still waiting. Yeah. If I don't stop, at the point that I stopped earlier, then the next point to stop is going to be when I'm testing 5821 becomes the factor, right? Come on, go. Go faster.
Should pick the smaller number.
Yeah, I should have. Should have picked a number that is not prime. This is a prime number. But the question is, how can I know this is a prime number when I only try potential factors up to 80? It has to do with 80 times 80 is 6400, which is greater than the number that I'm dealing with already. So how can I stop this early? The answer is, if it has a factor, okay, now when you find a factor of a number that is not itself, then you have the number divided by the factor, which is the other factor, right? So when you look at a factor pair, okay, I just went over a little bit. That's okay. I can go over, because I can just scroll back to 50. No, I'm not even there yet. Okay, never mind. It's 5821, right? So still have some ways to go. So the answer is, if A times B equals C, then it's guaranteed that one of those two, A or B, is less than or equal to the square root of the number. Yeah, I cannot talk and do it at the same time. Something did not work right. Sorry? What did I do wrong? Oh, okay. At some point it broke the. Let's do an equation. Oh, right there. I broke the equation stream.
Oh.
I think there's a quicker way to do this. I think I can do a control and double click this. Or shift. Nope. All right. So getting back to the point here, okay? If A times B equals to C, okay, A is less than or equal to the square root of C, or B is less than the square root of C. That has to be true. And that's why I only have to go up to the square root of the number. If I cannot find a factor up to the square root of a number, I know that number is prime. Is that making any sense?
Mm-hmm.
It takes me longer to do this than to explain the concept. It's probably a faster way to do this, but that part is still okay. That part is still right. But you can probably imagine, it will be non-zero all the way until we get to 5801, 5821. Okay. Okay. So the point is, this is a general approach. Now, when you look at this approach here, and you say, how do we code this in C and C++? What do you think? What control structure just screams at you and say, oh, we need this here? Now, we know we need some kind of assignment statements to change the values of something. We know that part. But what about control structures? What type of control structures have we talked about? Conditional statements and various kinds of loops, okay? So let's just say that I don't even care what kind of loop. So we only have two types. Conditional statement, which is a branch, or a loop that can do something repeatedly. Which one do you think is what we need here? A loop, right? Just seeing that I'm trying to repeat doing the same thing over and over again, tells you that we are doing something repeatedly, or a loop can do it. Okay. So now that we know we need a loop, what do you think needs to change per iteration so that we can say, okay, we are doing something over and over again, but we are not exactly repeating the same thing over and over again. Okay, what is being changed on each row? There are two things that are being changed in each row, but one is just a consequence of the other one. If you look at column C and column D, which one is the one that will change because the other column changed. Column D is changed because column C changed. So the only one that we are changing is really just column C, right? And the way we change column C, is it complicated and go like, oh, I don't know how to do that? Or is it something that we can do like, oh, we can do it with one single operator? Plus plus, right? Just increment something. Okay, so we have all of those elements. So just like with writing a paper in English, okay, so we know that we have a loop of some kind. We have some kind of plus plus, okay, we're incrementing something. We have a variable called n, where we have to find the factor from, and then we have a uninitialized variable f that we are supposed to, put the factor into. So we have all of these things here. How do you put this entire program together? N is already initialized, so we know that we don't have to initialize n at all. What about f? What do you think should be? What should we do with f, as far as initialization is concerned? Initialize to 2. Okay, so we now know that we have an f equals 2 somewhere before the loop. Okay, I don't know quite whether we need to use a pre-checking loop or post-checking loop. Now, when you're not sure whether you want to use a pre or post-checking loop, it is usually safe to assume that it is a pre-checking loop, and if things doesn't work out, you can turn it around and become a post-checking loop. But most of the time, we use pre-checking loops. So we'll go ahead and say, let's say this is a pre-checking loop, and I'm just going to put in everything that is in a pre-checking loop. What kind of condition are we checking? When are we getting out of this loop? When the remainder of the division is 0, right? So when n mod f is 0, we want to get out. So when n mod f is not 0, we want to stay in the loop. Is that making any sense? So that means n mod f goes here. Oh, Tech, you're missing something here. But what about that not equal to 0? It doesn't have to be here. Because once again, remember what is true and what is false in C and C++. Tell me again what is true in C++. Anything that is non-zero. And when n mod f is non-zero, do we want to stay in the loop? Yep. That's why. Okay? Now, if you want to, and make it very clear, it's not wrong. Okay? You can always say, if n mod f is not 0, stay in the loop. Okay? This is not incorrect, it is just unnecessary. Okay? But it does make the code easier to read. So personally, I would do this, just to be sure that we are looking at the result of the mod and stay in the loop as long as it is non-zero. But the other form is correct also, it is just more cryptic. What do we do in the loop? What do we do per iteration? What do we do with f? Increment. That's it. That's the whole algorithm. Now, this one is not smart, okay? This one will go all the way to f. It will only terminate when f becomes 5821, when n is 5821, okay? But it will still give you the right answer. So as far as correctness is concerned, this answer will give you full credit. I have no reason not to give you full credit because it will find the answer. Are we doing okay so far with this one? Okay. Let's go to the next example. Okay, so to some of you, this one you have seen already in the previous class. Yep.
So you said it's not smart, so make it a smart-wise, you just add like the statement to where.
Right. Yeah, to make it smarter, okay. Yep. Roshi. Oh, I almost forgot again. Yep. Okay, to make it smart, then we are going to say we will stay in the loop, but now we have two conditions. So we want this condition to be true because if n mod f is 0, we are still getting out, no problem. And we cannot spell and, we have to use ampersand here. The other one is we want to make sure that f times f is less than n. That's the other condition to stay in the loop. Because what that means is, as soon as f is greater than or equal to the square root of n, we're getting out. This is just another way to do it. But instead of using square root, I'm using square. Why do you think I do that? It's because square root is more time consuming to compute. The square of an integer is quick to compute, but the square root of a number is more time consuming. So that's why I use this method. It boils down to the same thing, right? But it is quicker to compute. But if I do it this way, I also have to have a potential problem at the end, because if at the end f times f is greater than n, then I have to do one more thing, because if f times f is greater than n, that means f is not a factor of n. It is just an indicator that n is a prime number. If n is a prime number, then the only factor of n is itself. So I have to add the conditional statement to fix that. Are there any questions about the second approach, the quote-unquote smarter approach? It terminates the loop a lot faster, but you also have to remember to do that one little conditional statement afterwards, because otherwise f is not a factor of n at that point.
So the second example you just gave us is a preferred, more intelligent way of doing it.
It's just a lot faster. When n is a prime number, this is a whole lot faster. Now, how much faster depends on what type of prime number we are talking about. Because the larger the prime number, the factor of gain is higher with this approach. So now let's move on to the next one, the next mock question. And the next one is this guy here. Okay, so here's the question. N is an integer, has an integer value. It is at least 1. You are also given an uninitialized variable f. And this time I want you to write a code to find the smallest value of f such that f factorial is greater than or equal to n. So how would you do this? Now with this one, I have to allow you to use a third variable. Okay, so assume that you can use another variable, let's say x, in the process. Okay, so what are we doing here? What we are doing in terms of a spreadsheet, I'm going to open a new sheet for this one. So let's say we're dealing with 5821 again. Okay, that's n. So what I want to do is to say, what is 1 factorial? Well, the factorial of 1, oops, is just 1. Is 1 greater than or equal to 5821? No? Did I say greater than or equal to? Yeah, greater than or equal to. So we want the factorial to be greater than or equal to the number that you're given with. So this is n, this is potentially f. Doesn't work. Okay, let's try 2. So we say this number plus 1 is 2, and then we just repeat the formula. The factorial of 2 is just 2. Is 2 greater than or equal to 5821? Nope. Let's move on to 3. Is the factorial of 3? No, doesn't work. So it seems like we have the same issue as last time. It's going to take me like a whole minute to scroll down to find the number that fits. Well, factorial grows really, really fast. Okay, so it won't take a whole lot of rows to get to that one. Okay, the next one is 24, 120. You can see how fast it's increasing. And the next one, 8 factorial, is already greater than or equal to that number. Okay, so we have found it. Okay, so the answer in this case is 8. Okay, f should be 8 when your algorithm completes. So the question now is, what does the algorithm look like in this case? So remember this time you do have to use another variable. Let's call it x here. So what you want to do is to say you use x to keep track of the factorial. Okay, so x is f factorial. F starts with 1, and so in this case it is already initialized correctly because x being the factorial of f is 1 is correct. 1 factorial is 1. So now you can say while as long as the factorial of f is less than the number that you're given with, which is n, what you want to do would be two things. One is to increment f itself, because you're computing the factorial of f, so you have to increment that first. Then you can say x multiply equals to f, which means x gets x times f. So now you're keeping track of the factorial. You first bump up the number, and then you say, oh, what is the factorial of this number? Wait, I know the factorial of the previous number already. I just have to multiply the factorial of the previous number to this number, and now I have the factorial of this number. And you just keep doing this until f is no longer less than n. Then when that happens, when x is greater than or equal to n, that f is the answer to this particular question. Any questions about this particular one? Questions? Yep.
What's the symbol with the asterisk equals and what is that?
X asterisk f, f asterisk equals f. This is the same thing as x is x times f. It is called a compound assignment operator because it is an assignment operator, but it is also performing an implicit multiplication of the left-hand side to the right-hand side.
Now, I know that the instruction says that n is initialized as an integer and at least 1, but when we write the code, we have to include that in our code.
No, when you write the code, the assumption is basically saying, what is the precondition before we reach execution of your code. So all it says is, by the time we get to your code, it is guaranteed that n is at least 1. So you don't have to account for the cases where n is like 0 or a negative value. All right. Any other questions about? Yep.
What does it do?
There's no due date. These are parts of the mock exam question. So I'm just going over this to give you guys more exposure of what kind of algorithm I might ask you guys to write in C and C++. Any other questions? Now that I have asked about these ones, it means it won't be the actual question next Monday.
Something.
It'll be something else, right? Exactly.
On Monday, can we go over the four sort of test questions?
On Monday, we may not have time to do that. I can start a forum. I think that would be a good idea. I can start a forum because we don't actually have a lab time for this class, but I can use a forum so that you guys can, you can talk to each other, through the forum, and I'll pop in, from time to time to answer questions too.
The exam is on Monday, right?
Huh?
Exam is on Monday.
The exam is on Monday, correct? That just ruins your weekend, right?
Yeah.
But I have to prepare for that too, so I'm not
Too pleased.
Hmm?
You're not too pleased.
Well, I mean, it has to happen.
You can move it to Wednesday.
Hmm?
Move it to next Wednesday.
Nah.
That's where you can enjoy the weekend.
All right. So I'll see you guys on Monday, and remember, Monday is the exam. So bring anything that can help you, and just make sure you have it ready before the exam.
Do we need a paper like last time?
No, just like no. With this one, you can just write on it.
Did you say we can bring anything like open?
It's open book, open notes, just like with all of my exams. Yep.
So I had a question on
Yep.
for homework. So converting files to zip files.
Mm-hmm.